Okay, looks like we're recording. Good evening, everyone. Welcome to our webinar tonight on how to maintain good indoor air quality in these days of COVID, so that as we start to regather for in-person worship, we can make sure that our members, our congregants, and everyone is safe. My name is Jim Nail. I'm president of Massachusetts Interfaith Power and Light. So we're delighted that you're all here with us tonight. This is recorded, so be conscious of that, but then that recording will be made available on our YouTube page in the next day or two, once I can get it uploaded there. And then please feel free to share it far and wide. We think this is important information that many people can benefit from. So we hope you will spread the word around for sure. Many of you probably know Interfaith Power and Light already, but a quick reminder, if I can advance the slides here, if it will let me do that. Why is it not letting me do? There we go. We're an organization dedicated to putting faith in action for climate justice and to address the climate emergency. So tonight's information and presentation is a little bit different than what we typically do, where, as you can see here, our mission is to first pray and make that connection between action to address the climate emergency and what we believe as people of faith, to help strengthen our motivation and strengthen our journey as we work on that. Then second, we help you act by installing solar panels, by making your house of worship more energy efficient, by helping you think through the kinds of things you can do to lower your carbon footprint. And then finally, to mobilize. We certainly need the right laws, policies, regulations to address climate impacts at the societal level. So in doing these three things, we hope we can really bring together a significant group of people to have the kind of impact that we need to reverse the climate problem and mitigate some of the damage. So as I said, tonight we're not going to be talking about these kinds of things, but the topic of resuming in-person worship is so important to all of us. We thought that this was really important information that we should share with you. I will put one plug in for the National Interfaith Power and Light Organization in, I guess it's about 6 weeks from now, have their annual Faith Climate Action Week, this year focusing on food and the connections between food, faith, and climate. And if you go to this faithclimateactionweek.org website, you can sign up to get all sorts of materials to help you think about activities you could do. I think they've got a film that you can access and show to your congregation. And there's a place to list your activity. So if you do decide to be part of this, please put up there what you're doing. And then that will be great that we can share what we're doing there. Quick word of logistics here. We're going to, since we've got 95 people here, it could be a little chaotic if we tried to do questions over voice. So we're going to try to do that in the chat. So you should be able to see a little chat icon here on your screen, and then you'll pop open this little side panel. You can type in your message there. We will keep an eye on that. I'm joined here by Bill Schroeder, who's another member of the executive committee. So the two of us will keep an eye on that. And probably mostly at the end, if we see something that we think is particularly important to address at the moment, we'll interrupt our speaker to do that. So last word here, a little bit of a disclaimer. We're providing information that's intended to provide general guidance on the important factors you should address as you're creating your post-COVID plan for returning in-person worship. Of course, each faith community and each worship building is unique, And so the ideas and suggestions we're going to present here must be adapted to those unique characteristics of your facility. But hopefully we'll get some of those questions and help you think through some of those things as well. All right, I think we've got the preliminaries out of the way. Without further ado, let me introduce our speaker tonight, Professor Curt Freedman. Professor Freedman is a professional engineer and also has his own engineering firm, CMF Engineering, that does energy management, HVAC design and controls, water and utility conservation, boiler design, chiller design, all that kind of important work to make sure that those kinds of systems are appropriate, sized well, and are efficient. In addition to that, he is an adjunct professor at Western New England University in Springfield, Massachusetts, where he instructs energy management and alternative energy, a high-speed camera library, a heat pump laboratory, and he teaches the juniors, seniors, and graduate students at the university. He's also a member of a number of professional organizations, the Association of Energy Engineers, the Association of Heating, Refrigeration, and Air Conditioning Engineers, American Society of Mechanical Engineers, the National Society of Professional Engineers, and others. So we're really, really happy to have Professor Freedman with us tonight. And with that, I will stop sharing and Curt, take it over.
I get the full screen right here. There we go. Everybody see a full screen now? Okay. Everybody hear me okay?
Yep, we've got it.
All right.
We're good to go.
Anyway, thank you for having me. I'm really humbled to be here tonight, and humbled and grateful for just a wonderful response and turnout. And the information here is intended to benefit everyone and help protect everybody's health. All right. Anyway, indoor air quality is fundamental to protect human health for any building occupancy. Rooms of assembly, such as sanctuaries or houses of worship, are especially challenged with COVID to meet expected standards for air filtration, as well as temperature, humidity, air circulation, treated outdoor air, and energy management. The recommendations that follow include both HVAC technology upgrades and human actions to synergistically reduce the risk of COVID transmission for the best interests of the community. Such HVAC upgrades must work in concert with a comprehensive plan of social distancing and other guidelines established by the CDC, the Commonwealth, and other health agencies. Our outline will include kind of an HVAC 101, maintenance and commissioning of HVAC systems, the CDC and other established standards for occupancy, social distancing, ventilation, and face mask use, ASHRAE 62.1, which is the ventilation standard, and room of assembly, social distancing, seating, entrance, and egress planning. We're going to be covering some basics of ventilation theory, some examples, some proposed ventilation guidelines, the use of carbon dioxide controllers and monitors, MERV 13 filters, and some other technologies. And then we'll have some time for a discussion at the end. Some lessons learned from our past. Going back over 100 years ago, schools were closed, churches were closed, and the world was reacting to a flu epidemic that it hadn't seen in a very long time. Face masks were mandatory 12 years before any virus could be seen with an electron microscope. Ventilation. You see the barbershop outside, and you can see the sign On the right, keep your bedroom windows open, prevent influenza, pneumonia, tuberculosis. So people knew more than 100 years ago the benefits of improved ventilation. And they knew the benefits of the utilization of best available technologies. All right. We'll get into a lot of detail, but part of providing for COVID is to understand your mechanical systems, your ventilation systems. Some more modern buildings may have central ducted systems, other older buildings may not. And so you have to kind of get to know your building. I'll have recommendations for both modern buildings and older buildings in this presentation. Kind of the fundamentals here. So here we have our room or space. And the green is air recirculation. And the blue is, I call it relief air or exhaust air. And the yellow bring fresh air in. So we do both. We recirculate the air and then we remove air and bring fresh air in. We're also looking at human comfort. We assemble inside of buildings. We live in New England. New England, for the most part, is very uncomfortable. So we have to provide comfort. We have to create a shell around us to maintain basic human comfort. We also want to filter out dirt and dust. Human beings are actually rather fragile, and we have a specific comfort zone. If we're looking at air conditioning loads, we look at the heat gain by people, lights, and equipment. We look at solar gain, and all these factor into providing comfort. To provide adequate fresh air, we have to use instrumentation. We call this doing air balances to determine how much fresh air we're providing now and what we would have to increase that fresh air to maintain reasonable ventilation rates. So this whole series of equipment that can be used for that. We have anemometers, flow hoods, air velocity probes. Here, this gentleman is measuring airflows to an intake hood on a rooftop unit. We can adjust the speed of motors and blowers using adjustable shivs or variable frequency drives. And mechanical systems can be very varied depending on the building, the age. But it's important to have an understanding of this so that adjustments can be made. Infiltration, we talk about infiltration. We talk about ACH, air changes per hour. And a building is considered tight if you have a quarter of an air change per hour. That's where 1/4 of the whole room volume changes each hour. Average is about 0.5, and 1 or greater would be considered a building with high leakage rates. Modern versus old. So here's a beautiful old sanctuary, very classic, certainly more than 100 years old. This provides certain challenges because we don't have a central ducted system. So if we're going to introduce greater amounts of fresh air, we can open up doors and windows. We can use a carbon dioxide monitor to test to see if we're having adequate fresh air. We can use window fans and ceiling fans, and we can use freestanding HEPA filters. And we also notice this space certainly is at full occupancy, and it's going to be some time before we have full occupancy again. Old heating systems, old radiators. So to improve ventilation, we can put in these window fans in the double hung windows. We can open up doors. So there's many ways that you can provide fresh air. And you can do a determination of how many people will be attending and determine how much fresh air that you need to be able to provide. We can use freestanding HEPA filters. These units are about the size of a kitchen wastebasket. And all the air that circulates through these, it's like having fresh air being introduced because they will filter out some 99% of any potential virus particles. I'm using these actually in my classroom at the university. And once again, we can use carbon dioxide monitors. or controllers. For a more modern facility, which does have a central ducted system, we're going to be looking at carbon dioxide controllers. Kind of looks like a thermostat. And this senses the carbon dioxide in the air and then activates exhaust fans or opens up louvers to bring in fresh air. Ceiling fans can be utilized to provide recirculation of air. Of course, we have rooftop units. Once again, the type and number of HVAC apparatus is very varied, but it's up to you to get to know your building and do a survey of the type of equipment that you have. This particular rooftop unit has an air intake here and these louvers for economizing, but this also can be used to bring in fresh air in a controlled way with a carbon dioxide controller. Maintenance and commissioning. HVAC mechanical systems should be recommissioned at least once a year or seasonally. You want to make sure that if you're bringing in more fresh air that you don't cause a freezing situation. So once again, you have to survey your building to make sure it can work properly to bring in adequate amounts of fresh air. You can also introduce air-to-air heat exchangers for energy saving purposes and also to allow your systems to bring in more air. ASHRAE standard 180 is an excellent reference for the determination of commissioning and maintenance standards. Okay. Now, very recently, Governor Baker increased the occupancy of houses of worship from 25% to 40%. And although some people might welcome that news, I will explain to you shortly that realistically, 40% is very difficult to achieve. By the time you maintain social distancing, it's very difficult to achieve. So I'm recommending that we look at social distancing and also certainly maintaining adequate fresh air. Now, the CDC says that we need to ensure that ventilation systems operate properly and increase circulation of outdoor air as much as possible by opening windows and doors, using fans, etc. My issue with this, it lacks specificity. So from an engineering point of view, I look at this recommendation and I don't know what to do with that. And so I'm providing much more detailed direction so that we can minimize risk and at the same time maintain reasonable comfort in our facilities. First recommendation is the use of masks. This is a typical N95 mask. These are readily available now. Vendors offer them. These are real and they work. And I'm recommending, this is my preference, I'm recommending that all parishioners wear N95 masks because they work. These can be provided. It's my recommendation that the host facilities purchase these in bulk and then distribute them to their membership. I am recommending that although there are exemptions, medical exemptions, if you're 2 years or younger, if you have medical, and I don't mean to be harsh, but I'm making these recommendations to be kind. I wouldn't want anybody to get sick unnecessarily. And so it's my recommendation that all participants wear masks, including the lay leadership and leadership of the institutions. And I practice what I preach. This is yours truly at the head of my class, wearing a face mask, and I have a wireless amplifier. And I'm able to speak clearly and distinctly to my students, even across a large room. And this works, even for speaking for long times, it makes it much easier. So I'm recommending that everyone wear an N95 mask. I'm recommending that bandanas and gaiters not be allowed because they have very poor performance. Face shields without masks should not be allowed. And there should be no medical exemptions, understanding that some people would not be able to attend. This is my recommendation, preference. Each institution would have to make their own policy. This is N95 mask here, and we show a bandana down here, much lesser filtration efficiency. Here's another view of it. So bandanas don't work very well. N95 masks do. It is the best available technology, and they are readily available. We also need to develop guidelines for entering and exiting. And this is also part of the Massachusetts and CDC recommendations. You want to have maybe arrows on the floor using mats or placards or stickers. You also want to mark off seats that you don't want people to sit in. You can have staff or other volunteers help usher or direct people in and out of the facility. And you want to have kind of a policy where people enter first, leave last. So it's done in an orderly way. So when people are entering or exiting, they don't have to come in close proximity to one another. ASHRAE standard 62.1 is essentially the world standard for how much fresh air is needed for different types of applications. Carbon dioxide itself is not a risk factor, but carbon dioxide, which is one of the products of human respiration, also is accompanied by virus particles, water vapor, and odors and things like that. And so it's been determined that in the past, we want to have levels of carbon dioxide of about 1,100 parts per million or less, or 700 parts per million above ambient. And that'll give us, that's equivalent to about 15 CFM per person. And this is an accepted standard which has been on the books for decades. However, when we look at the ASHRAE standard for religious houses of worship, they recommend 5 CFM per person plus 0.06 CFM per square foot of that sanctuary. So 100 persons in a sanctuary that's 2,000 square feet, you'd have 500 CFM for the people and 120 CFM for the room space, totaling 620 CFM, or about 6 CFM per person. I'm commenting here that ASHRAE 62.1 is not adequate. I believe it's based on trying to take advantage of the large volume of a typical sanctuary, but it doesn't meet the needs of a COVID world. Let's see. Here's an example of modern theater seating. And typically we have 36 inches or more between rows, and we have about 7 square feet per seat, versus the old is measurably smaller. Here's an example of a sanctuary seating about 466. The pews in the back here are the older style. They're less than 36 inches apart. In the front here are some freestanding chairs. So here's the fixed seats, once again closer than 36 inches. Here's some freestanding chairs, which are 36 inches apart. And so I went through the exercise. You can see the blue dots, and let me see if I can zoom in on this. I can't zoom in on this. Okay. The blue dots are where I determined that available seating was. Notice here, I have people seated every third row because it's less than 36 inches between. So every third row, and here we're every other row, but I've provided distance from the aisles. And then each section, think of it like tables in a restaurant. So each section, I determined how many family units and how many people could sit in each family unit. And I came up with a total of maximum 108 out of the 466, less than 25%. But realistically, just like seating people in a restaurant, I mean, you might have a table that could seat 6, but a party of 4 comes in that wants to sit there. So your seating capacity is only 4 out of the 6. So despite best efforts, your actual occupancy will be significantly less than the theoretical amount. And so here's some examples of this. So typically, when you go through this, although the governor is allowing 40%, realistically, you're looking at about 20%. So the institutions are looking to plan for, let's say, Easter. They want to accommodate as many people as possible. I don't think you can plan at 40%. You need to plan at 20%, which means that you would have to have a greater number of services throughout the day to accommodate the needs of your parishioners. Offices, the present standards are within 40% of maximum permitted. Once again, by social distancing, I'm not sure if you can reach 40%, or 5 persons per 1,000 square feet. Opening windows and doors, many offices may not have central HVAC. So you're looking at HEPA filters, you're looking at monitoring air quality with carbon dioxide monitors. And once again, the use of face masks is vital. Schools, once again, the 40% of maximum permitted occupancy, 5 persons per 1,000 square feet. Once again, maintaining social distancing, the use of opening windows, HEPA filters, things like that are recommended. And once again, the use of face masks. But once again, we talk about air changes per hour, ACH, and we also talk about the need for CFM per person. I like to focus on the CFM per person because that's really what's relevant. If this black square is a room, we have air ventilating through the room, and we have air leaving the room. And the C, that's the carbon dioxide entering the space. That's from products of respiration of human beings sitting in that space. And so scientifically, we can do a balance of air entering, leaving, and carbon dioxide entering and leaving. The science for this is well established. We look at the metabolic equivalent of task, which basically is the human activity level. So if someone is at prayer or worship or reading, that has a MET level of 1. If someone is doing much more rigorous activity like chopping wood, you're going to be off the charts here at a 5 to a 7. And so the level of human activity determines how much fresh air we need to provide. And so based on these rates, and to just give an example of what this might look at, if you had to put a human being in this very small tent, and if you provided 3/4 of a CFM for that one person there, the carbon dioxide levels would soar. That's the red curve, within minutes to unacceptable levels. If you maintain 15 CFM per person, right, you maintain good air quality right along. If we have a larger hall, if you have 0 outdoor air ventilation, your red curve, but once again, it reacts much more slowly because of the added volume. And the blue is the 15 CFM per person. So this gives you a sense of the dynamics in terms of how fast or slowly the air quality degrades. And so you can see how important it is to have ventilation. So if you can have kind of continuous occupancy. So in your church, if you have multiple masses at Easter, you have to have adequate ventilation because you don't have time to ventilate the room after each use. It'll be essentially kind of continuous. So you have to make sure you have more than adequate ventilation throughout. Once again, the reason why this works is that typically, let's say if we're going to have a maximum of 20% occupancy, if a space was intended or designed for full occupancy, it means that we could bring in 5 times as much air to meet the needs of the 20% who are there. So we can increase the outdoor air ventilation by some 5 times or more to provide the maximum amount of fresh air without compromising the comfort standards of that space. So we need to determine the maximum occupancy in the space. You can determine the maximum cooling or heating load to provide for that occupancy. And you want to set the outdoor airflow rates to meet that criteria of the equivalent of 100% occupancy to meet the fresh air needs of the 20% who are there. So that's the trick. That's the recommendation, so that we can say we're maximizing the potential ventilation for that space to minimize the risk of COVID transmission. So the ventilation rates for the circulation, not the outdoor fresh air, just the circulation. This is to maintain adequate heating and cooling. 0.75 CFM per square foot and 25 CFM per person. And the exhaust or outside air is 45 CFM per person, controlled by carbon dioxide controller. If you can provide HEPA filters or MERV 13 filters, then you can reduce from the 45 CFM per person. Carbon dioxide controllers come in different forms. They're made by many different manufacturers. Price range of these tends to range from about $300 to $500 each. They also have an advantage, is that they will actually save energy by limiting unwanted ventilation during other times and maintaining sufficient ventilation based on the occupancies that are in the space. So they're both preserving health and also help control costs. But here's another example. So we have an example of 100 persons. Here's a space that's about 6,000 square feet with a 25-foot ceiling. It's got 100 persons in attendance. And if we do nothing, we follow the red curve. And so within about an hour, we're kind of at the threshold of inadequate air quality. If we follow the green, which is the 15 CFM, we maintain levels of, go up to about 850 parts per million after about 4 hours. And if we maintain 45 CFM, it's a blue curve, we maintain levels of under 550 parts per million carbon dioxide indefinitely. So this gives you a sense of how providing proper ventilation, how it provides for that air quality. You can see it in a real-time format. If we have an example here of the blue, which is basically the ASHRAE standard, at full occupancy, we far exceed the limitations even in a non-COVID environment. The red, 50 people, 10% occupancy. So you can see how your facility responds. So if you're going to maintain good air quality, it requires much more adequate fresh air. If we look at it from the perspective of the potential COVID particle concentration versus time. So if we do nothing and don't provide fresh air, we follow the red curve. If we follow the 45 CFM per person, we follow the blue. So this gives you a comparison of how the different ventilation rates reduce the potential particle concentrations. The green is the 15 CFM per person. So having more ventilation makes a significant difference. You can see a dramatic difference by taking these steps of improved ventilation. MERV 13 filters are very much recommended for central HVAC systems. They work. They remove some 80% of the potential virus particles. They also remove dust. And once again, these technologies, not only do they prevent COVID transmission, they also prevent the transmission of conventional flu and the common cold. Freestanding HEPA filters can be used in a classroom. I'm recommending that one such unit be used for between 5 and 10 persons. So you would need one of these for every 5 or 10 people, like in a classroom. And this will offset the need to bring in excessive amount of outdoor air. You still need to bring in fresh air, but maybe not as much. And these are very effective. They're tried and proven. The science clearly substantiates their use. The air ionizers have been very popular. In my community in Long Meadow, they were put in all the schools, but they are not recommended. They produce ozone, which is an irritant to human respiration, and so I will not recommend them. Ultraviolet light does kill bacteria and virus particles in an air handler, but it has very limited effectiveness on the moving airstream. It takes a lot of power to do so. You can use these to sterilize surfaces, such as bathrooms and things, but they have limited effectiveness on moving airstreams. They are being used during after hours to sterilize surfaces on public transportation and restrooms and things. But see, it takes a long time for the light to take effect. The air moves past too quickly for the ultraviolet light to be effective in a moving airstream. There are air purification units, which are set up on the bypass. And these are effective because inside of here, there is sufficient time to zap the virus particles. And these are being utilized effectively. Okay, the main conclusions. The use of carbon dioxide controllers can be utilized to provide the maximum outside air ventilation based on HVAC capabilities with design weather conditions and occupancies of 15% or less. Additional mitigation steps include the following: use of the N95 masks for all participants, the installation of MERV 13 filters, the use of ultraviolet light on surfaces, and once it may only provide partial effect on airstreams. And as far as bipolar air ionization, I am not recommending their use because of concern for ozone production. And in closing, anybody recognize the name and location of this very famous house of worship? Anybody?
Feel free to put it in the chat. Any of you who can recognize that.
National Cathedral.
Oh, there you go.
Very good. Yeah.
An N95 mask for them. Great, Curt, that's a ton of information. Really, really helpful stuff. I know there's a bunch of questions that have come in, so let me
Sure.
have Bill share those with you, and we'll dig in on some of the questions people have.
Okay, can you hear me, Curt?
Yes, go ahead, sir.
Okay, good. One question was, what about recommendations for this fall, assuming that conditions get better, there's more vaccination, less of the COVID around, how would your recommendations change for the fall?
If everybody gets vaccinated and the COVID counts go down, the use of improved filtration is still beneficial to reduce the risk of conventional flu or common colds. And the need to provide minimum or basic ventilation based on non-COVID standards will still exist. And so the use of carbon dioxide monitors and controllers will still be relevant. And by maintaining proper air infiltration, you'll be providing the necessary amount of fresh air, which will help reduce your utility costs.
Okay, another question that a number of people have had has to do with the use of ceiling fans in sanctuaries, particularly when you're not talking about drawing in outdoor air and exhausting air to the outdoors, but rather just using the ceiling fans to circulate the air downward.
Okay, ceiling fans by themselves is not sufficient. You need the ceiling fans to mix the air, and you actually want to, if there are any potential virus particles, you want to dilute them. You wouldn't want, for example, concentrated particles drifting over to the person next to you. You want the ceiling fan to mix it immediately so that it's dilute. It's still necessary to bring in outdoor air because that's what's necessary to control the carbon dioxide levels so that you know that the other products of human respiration are also being removed, including virus particles, water vapor. Water vapor is emitted in an equal proportion as carbon dioxide. And so by controlling water vapor, it'll make things more comfortable, especially during the warm months. So it's still important to maintain adequate and proper amount of outdoor air to dilute any undesirable products of human respiration.
Okay, so how would you do that if your system is not really designed to draw in outdoor air? Open windows and doors?
Windows and doors, and also in the slides I showed the use of window fans. In many buildings, you might have louvers that are convectors. So like in the summertime, you might use them to allow fresh air to rise up through the sanctuary as kind of natural ventilation. And yes, and for this coming spring where it might be cold, your house of worship, the sanctuaries might be cold. Encourage people to bring a sweater or maybe keep their coat on or something, because it'll be more important to provide for health than to ensure comfort.
Okay, another question has to do with people who have been vaccinated. How would your recommendations change, if they would, for parishioners who have been vaccinated?
The standards are that people who are vaccinated still need to wear masks. The laws haven't changed, but perhaps in the future, people who have been vaccinated would be exempt from wearing masks. But right now, everybody still needs to wear masks. And even if you're vaccinated and it's 90% effective, it means you have a 1 out of 10 chance of still receiving the virus. And you don't know if that vaccine is effective for you. So you want to avoid getting it. So you need to take the same precautions as anybody else would, because you could still get it even if you've been vaccinated. Until the virus counts get way down, it's a numbers game. So if you have a room where there's 100 people in it and 2 out of 100 are carrying the virus, your chances of coming into contact with someone is 2 in 100. If we reach herd immunity and the virus count goes way down, instead of the COVID count being 2%, if it's 1/10 of 1%, then your chances are much less. So everybody needs to wear a mask, even if they've been vaccinated, because a vaccine is not a guarantee. It's an improvement to lesser risk.
A quick question, since we're talking about window fans, should they blow in or out?
I'd recommend they blow out so that cold drafts don't impinge on people. If they blow out, it's going to make the building negatively pressurized. And that way, no one's going to have cold drafts. Someone sitting next to the window won't feel a cold draft. And so I think that's the better alternative. And it still maintains the same air quality, but it prevents kind of the cold draft scenario.
Somebody asked about N95 masks. Where can you get them and how much do they cost?
Okay. I am buying them. I have no vested interest in this company, but I'm buying them through WW Grainger. WW Grainger has hundreds of outlets all across the country. They tend to be geared for the commercial and industrial sector. I buy them in lots of 40 at $110 for a lot of 40. It's about $2.80 a piece. I can order them and have 11,000 dropped at my door in a 24-hour period. So that's one source, and there are others, but I find this is one opportunity, and I know that their quality control ensures that these masks are legitimate.
P. Brown asks, could we designate an area for fully vaccinated and pack people in there at normal distances, not remote from each other, but remote from the rest of the congregation, like maybe the balcony for denser seating for fully vaccinated only?
The full answer to that question is beyond my pay grade. All I can say is the present code does not allow for that. Perhaps in the future, but the present law and CDC recommendations don't allow for that, primarily because once again, the vaccine is not 100%, it's 90%. So it's still a 1 out of 10 chance, a better chance, but you still have a chance. And so we're not there yet.
A practical question, do your recommendations include allowing singing or not?
I think people are recommending quiet singing. And I don't want to remove the joy from people. If you wear a mask, I think you're in good shape. But I think that's certainly part of it. And I'm not going to ban singing, but it can be done discreetly, because that's certainly it's part of that soulful experience that we all cherish. And that's one reason social distancing, the masks, the ventilation. And once again, if a human activity level increases by singing, the carbon dioxide controller will take care of that. Or the monitor you have will say, oh, now we got to open the doors a little bit more. So the real-time monitoring of the situation is taken care of with the carbon dioxide controllers or monitors.
Someone asks, what is the carbon dioxide level that is dangerous?
Carbon dioxide by itself doesn't become dangerous until you exceed 5,000 parts per million. Okay, so the levels that we're recommending of typically 600 parts per million, it's part of the overall package of everything that exists as part of human respiration. And the carbon dioxide itself is an indicator, but the carbon dioxide itself is not the hazard.
Here's one that I love, which is, our pipe organ draws in outside air. Should we play it really loudly all the time?
Whatever makes people happy and purposeful and closer to God, I fully support.
Here's a good question. Can we use, they're all good, of course, but can we use a portable CO2 monitor to assess our environment during various occupancy activity scenarios? Where all can we use these things, or should we?
Yes, this one is clearly portable. Many of them are, here's another one, they're battery powered. And so, yes, I recommend, so there should be a designated person that's in charge of monitoring the carbon dioxide. And maybe they're sitting in the middle or the back. And so if the level should creep up to, let's say, more than 650 parts per million, then they would give a signal to the ushers to maybe open the windows a little bit more or to turn the fans up a little bit more. And so that way you get real-time monitoring of this. Because it's really important, because if you compromise on the CO2 concentration, it means the other particles that are part of the human respiration are getting to levels which could compromise the human health or safety. And that way you can immediately address it. And that also gives everybody comfort that we're all actively maintaining the best possible air quality for everybody's benefit and safety.
Question on MERV 13 filters, or actually a couple. Are they a one-for-one swap with conventional filters? And how much do they cost?
Sometimes, depending on the width of your filter cabinet, the MERV 13 filters are thicker, so they may not fit. So sometimes you have to modify your filter rack for them. Prices range. I'm not going to quote them exactly. I've seen they're significant price, and they are significantly pricier than your conventional filters. Commonly, people will put a conventional filter media up against it just upstream, so that conventional dust doesn't require the MERV 13 filters to be replaced. You can get much more life out of them. But generally, the MERV 13 filters can be accommodated in conventional systems. You do want to make sure that you get adequate airflow. And so you want to check when you run your furnace or your air conditioner to make sure you're getting adequate airflow. But usually, in about 90% of the cases, your systems can handle a MERV 13 filter.
And while we're on filters, someone's asking, what's the difference between a MERV and a HEPA filter? I'm confused.
HEPA filters are much thicker and will remove about 99% of virus particles. A MERV 13 will remove about 80%. So after repeated passes, they're removing a greater proportion. A HEPA filter are commonly installed like in a hospital environment, where they have actually very, very powerful air handlers that can overcome the very significant pressure drop across the HEPA filters. A MERV 13 filter is retrofit into existing commercial or even residential air handlers. And they have a much lesser pressure drop, which is still compatible with a conventional air handler.
So you probably can't put a HEPA filter in a conventional air handler because of the pressure drop, but you could have portable HEPA filters.
Right. And I pointed those out in the slideshow, and I have them in my classroom at Western New England. I have 3 of them in my classroom. I have 16 students in my classroom. And they work, all you do is plug them in. They're very simple, and they're readily available. The units, which are called residential size, about the size of a kitchen wastebasket, they run about $250. But they're effective, and especially if you're in a say classroom situation where you don't have a central HVAC and you want to do something. Well, first of all, face masks, HEPA filters, and still opening the windows to bring in fresh air as best that you can, and you still want to monitor with a carbon dioxide monitor, and then you should be in good shape.
Someone asks, what was that cubic feet per minute per person equation again to size exhaust fans?
You want to have a total of about 45 CFM per person. You can reduce that if you use HEPA filters or MERV filters. And then for just air circulation, you want to have about 25 CFM per person, plus about, I think about 0.75 CFM per square foot. And that's simply to provide adequate heating or air conditioning for the space, so that your central air handler has enough air circulation to put out the BTUs to either heat or cool.
Do you think that freestanding HEPA filters would be useful in a large sanctuary with a high ceiling?
Yes. If you have ceiling fans or other types of air distribution, if you don't have ceiling fans, you could use pedestal fans. If you operate them at slow speed, they are quiet. Ceiling fans probably would be my best recommendation. I have observed that not all, but many sanctuaries have ceiling fans because it's become necessary to maintain some type of comfort in the summertime. Many of the older buildings also have ventilator grills, which have to be manually opened to allow kind of a chimney effect of air to circulate. So yes, you have to have both air circulation and air filtration. The freestanding HEPA filters could be positioned, in the empty pews, and that'd be a good place for them. And of course, you have to provide power for them.
So message to all participants, if you have questions that you asked a while ago and I haven't gotten to it, ask it again, please, because I'm picking up the new ones as they come in. So now another one, what is the current draw on portable HEPA? How many per circuit?
How many, ask your question again, please.
What is the current draw on a portable HEPA typically? How many of them could you have on one plug?
It's small. It's less than half an amp.
Okay. Filter box gasketing to eliminate bypass leaks. How important is that?
In a central air handler, you want to make sure your filters are proper fitting, especially if you have MERV filters. Otherwise, you're going to have a lot of air leaking in between the filters.
Right.
So yes, that's very important that your filters fit properly in your filter rack.
So again, on the HEPAs, how many freestanding units would you recommend in a sanctuary, and how much do they cost?
I'd recommend that one of those freestanding units service between 5 to 10 people. And I purchased 3 of them recently at $250 each. Okay. And they come complete with the filters all ready to go.
I think we might be running low on questions at this point.
A very good response to the questions. That's excellent.
Yeah, those are all great questions, and yeah, we are coming up on an hour, so probably good to let people get back to the rest of their evening, and Curt, let you get back to your evening. But thank you so much for all this. This was really great. I'll just put a quick summary on things and just make sure that I'm on the right path here, if you would, Curt. That basically, like, one of the first things to do is make sure you understand the equipment you have in your building, so that again, if you have some kind of furnace or air handling system, there's the filters and things you can do there. So that's really important. The other thing is, I'm kind of hearing this overall message of err on the side of safety, if there's any question whatsoever, in terms of, rather than going for 40%, even if that's what the state allows, think very carefully about the capacity to make sure you're maintaining social distance. Those questions about vaccination, we're still at a point where even by Easter and Passover, there's still going to be a lot of people not vaccinated. So err on the side of safety and continue to follow masking and social distancing requirements. And lastly, it's kind of more air and more air circulation is better. So it's like you kind of can't go wrong by having more fans or more filters and things to protect people's safety. All right.
Thank you. Yeah, those are all good. Very good.
All right. Great. Again, Curt, thank you so much.
You're welcome.
Really appreciate you being here. And thank you all for attending. As I said, look for an email from Mass IPL in the next day or two, and the recording will be posted for you to share with others in your congregation or other people that you know who may find this information really valuable.
I want to wish everybody a wonderful and safe holiday season.
Thank you. You
Thank
too.
you very much.
Good night, all.
Bye.
Right.